is. Does anybody have questions they want to ask about? Went okay? You either figured out what you...
I have
Yes.
a question on the third one. I just didn't get it.
The third one may have been somebody else's first one, so what was the,
It
do you remember
was-
the question?
The prime.
How many factors does a number with the prime power factorization
Yeah.
such and such have? Or which of the following has exactly 30 factors? Or how many factors does the number such and such have? Which one? First one. So it was 2 to the first, 3 to the second, and 7 to the first. Yep, is that right? How many factors does this number have? Do we need to know the number in order to find the number of factors? No. So how do we go about it? You raising your hand, or?
You add 1 to each of those and multiply.
Add 1 to each of those,
So to each of the exponents.
to each of the exponents. So add 1 to 1, we get, add 1 to 2, we get, and add 1 to 1, and we get 2, 3, and 2. Then what? Then multiply them, we get what? 12. This number, whatever it is, should have 12. We okay? All right. Any of the others? We'll assume you either got them right or you figured out what you did wrong and we're ready to go. On Friday, we were talking about divisibility shortcuts. Did anybody come up with a divisibility rule for 7? Anybody find one? Would you mind sharing it? Did you look it up well enough to, could you illustrate it with maybe an example?
Yeah, I could.
Okay. Nobody else looked up 7?
Yeah, there's stuff.
Okay. If is it Brianna?
Yeah.
If Brianna's method is not the same method that you found, I'd like to hear from you on that. Remember, I'm calling these divisibility rules, not divisibility shortcuts. I think they're interesting. I don't know how critical they are for speed or for shortcuts.
Okay, so with 7, what you do is you double the last digit, so that makes it 4. And then what you do is you do you take these first 2 digits and you minus that 4 from it, which would equal 63. Then you divide that by 7, and if it divides by 7, then the whole number is divided by 7. So this whole number can be divided by 7.
I looked at that one too, and I was looking up some rules on it, and it says it works really good with like short numbers, but as soon as you get into like long numbers, it doesn't work anymore. Because I actually started trying it on like bigger numbers, and it doesn't work.
You couldn't get it to work on bigger numbers. Have you got a bigger number that you tried it on?
I have them all written down, and I like deleted it because it wasn't working.
Let's just make one up. Somebody got a calculator handy? Go 7 times. We want 7 to be a factor, so go 7 times and then do up times a 3-digit number. What'd you get?
I got 2,506.
Okay, and that was taken when you went 7 times some number. Okay, so then we know this is divisible by 7, or should be. So the rule is to what?
You double the last digit.
Just pull the last digit off, double it, and subtract it from what you pulled it off of. So 250, and we're going to subtract double that, which is 12, gives us what? 238. Now if you can't divide 7 into there real easily, what do? Pull off the last digit, double it. What's that? 16, and subtract it from what's, wait a minute. Yeah, subtract it, yeah, subtract 16. We don't want to, we've taken this off, right? We took this off, and so 23 subtract 16 is 7. Now we can say 7 will go into there. So if it doesn't work the first time, just keep taking off the unit's digit, doubling it, subtracting it from the part you took it off from. If you get down here and you divide by 7 and 7 won't go into it evenly, what do you know? 7 won't go into this number either. That make sense? Okay. Did you find another one besides that one, or is that the one you found?
Yeah,
That's the one you find. Did you find another one? Do you want to come up and?
Okay, so I found one where you take each, so we'll just do an example. And you take each digit and multiply it by 1, 3, 2, and 5. So using this example, you do 6 times 1, so you do it the first one by the first place. So like this. So you do 6 times 1, and then you add them together. And then 1 times 3. And then 0 times 2. And then 2 times 6. And then so then you get 6 plus 3 plus 0 plus 12. So 9 plus 12 equals 21. So that's divisible by 7. And then you can keep going. So if there's more numbers, you just keep going, and then if it if you have more than 6 numbers, then you just repeat it again. Offline. I found it online.
Anybody have any other questions?
So she just asked if how I found the pattern just online, but then if you just keep, so if there was, let's say, 1 and 7, then you just keep going, so 4 times 1, and then you do 7 times 5, and then you do that, and then if the sum is divisible by 7, then the whole number is divisible by 7.
And you said that you just repeat the pattern again?
So if you go again, then you just start from here again.
Oh, that's true. I didn't know those numbers.
I found these online.
So it's just a pattern.
So have you ever wondered who comes up with these things? Do you remember if we had the word or the number I had on the board? How many digits did it have last week? Take either one of these. I think short division would probably be faster than either one of them, although they're interesting. Does someone have another one besides these two? You have another one?
Yep.
Okay.
Okay, so this one, for examples, what it tells you to do is to break up the numbers into pairs of 2 digits,
So like this would be 44. And then you take each section of those pairs and you figure out how much remainder there is to the closest multiple of 7. So like for this, it would be 42. So I'd subtract 42, because that's the closest 7 would get to that. I'd have 2. And then for this next one, 93, take 93 minus, no, sorry, subtract 98, because that's the closest multiple of 7 from 93. That would give you 5. And then for this 4, the closest multiple, 4 is just a remainder, you can't do anything with that, so you just leave it at 4. And then the 6, you would just do 7 minus 6, and that would give you 1. And then you would take each of these numbers and put them together, so you'd have the 2, 5, 4, 1, and then you would do it again. And so then you'd have, let's see, 28 minus 25 is 3, and with the 41, have, right, I'm going to write this down, 41 minus 6. You put those together and you get 63, and you're like, oh, 63 is a multiple of 7, that's great, that took my whole life. So the
Put them
numbers that you're
together.
looking for,
Why do
you
you-
put the 6 and the 3 together.
Why not 36?
I don't know, that's not showing me online. I guess because you, I don't know. That's a good question.
Let's see how you put together.
Because backwards.
You're going backwards. You did
That's
that above.
right. Yeah, because we did it above too. Okay. But the thing that makes this ridiculous is just like, that just takes forever. Especially if this number was any longer. Like you have to find each pair and find the multiple that's closest to it. So like, it can be above or below the remainder you're looking for, you know what I mean?
Mhm.
But then it's just so confusing because then, yeah, you have to reverse the order and then you have to keep doing it till you get to a number small enough that you're like, oh yeah, that's a multiple of 7.
Question, comment.
Well, I'm looking at it actually right now online, but it's not actually the closest, it's a pattern. So for the first pair, you use the lower multiple, and for the second, use the
Oh, that-
upper, and then lower, and then upper.
Well, on the website I looked at, it said upper or lower, and so I was like, oh, so it doesn't matter.
Yeah,
So
but then
lower,
it goes
upper,
on
lower,
to say
upper.
Gotcha.
it's, yeah.
Okay.
That's what that.
Is closer.
Yeah,
than
see.
98.
93. 42 is closer than 3.
Gotcha. So is it upper, lower, upper, lower? or something?
Lower, for the first pair, it's the lower, and then second is
Oh.
upper.
And then,
Okay. So there's 3 different ways that you could check the divisibility of 7. And by the way, that's not all the different ways for 7. That's all we found though. Okay, let's review. We got done with 2, right? 3, 4, 5, stop me if you have any questions. 6, 7 we covered, right? We said short division might be your fastest way, although these are some pretty cool ways. 8, we talked about 8, right? 9, what's 9? Yeah.
The way I learned was like you divide, or you subtract it by 1, and then like, however. I think like you subtract by 1. And
Subtract what by 1?
then 9, or like the number. I don't remember.
Okay. Yeah.
I read that you add up all the digits, and if it's divisible by 9, the sum of all those digits is the number.
It's exactly like 3, except you add the digits and you ask yourself, is the sum of the digits divisible by 9 rather than 3? By the way, if you add the digits and it's divisible by 3, maybe it's divisible by 9, maybe not, right? But if the sum of the digits is divisible by 9, and does everybody remember the even shorter cut I showed you for 3? about putting them in groups of divisibility by 9? Yes, should we go over that? Let's put one, let's just throw a number up here. 2, 7, 8, 6, 4, 5, 0, 1, 2. Is this divisible by 9? We could add them up and see if the sum is divisible by 9. Or I can put them together. 7 and 2 makes 9, 8 and 1 makes 9, 4 and 5 makes 9, 6 and 2 make 8. If it made 9, I would say yes, this is divisible by 9, but it's not, so this number is not divisible by 9. I don't even know what the sum is, but does everybody see how I grouped it in sums of 9? So if I were to change this number to 3, this number would be divisible by 9. Yes?
So when you're adding, what do you do if there's an odd number? Because you do have an odd number, but it's a 0 and it doesn't matter.
I could have put this 1, 2 with a 6 to get a 9, but then I wouldn't have had anything to put with the 8. It doesn't. They don't have to be in pairs. They just have to be in groups that add up to 9. Okay. Did that answer your question?
Yeah.
All right. So there's 9. 10, do we even need to talk about it? You've known it since 2nd grade? First? I'll bet first. You always counted 10, 20, 30, right? Okay, 10. However, let me just say 10 is the exact same rule for 6. What was 6? Check for 2 and 3. Well, 10 is exactly the same as 6, just check for what? 2 and 5. So if it works for 2 and it works for 5, now remember 5 is what? It ends in 5 or 0. 2 is it ends in 0, 2, 4, 6, or 8. And if it fits both of those, then it's going to fit 10. Well, both of them means it ends in 0. But do you see how it applies to 6? Okay, does anybody know the rule for 11? Let's check this number for 11. 11's pretty fast. So I think it really is a shortcut. You start on either the left or the right, it doesn't matter, and pair them up every other number. So here, 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 and there. And then pair up the other ones that we didn't have. And then you get the sum of each of those. So 10, 14, 16, right? We have 13, 18, 19. If I take 19 minus 16 and get 3, is 3 divisible by 11? Then this number is not divisible by 11. Somebody who's got a calculator, let's make up one that does work. Go 11 times a 6-digit number and give me the result. 11 times, just make up any 6-digit number. If you take 11 times it, we'll have a multiple of 11, right? That should be divisible by 11. You got one?
3, 1, 4, 9, 7, 6, 2.
Is this it? Okay. Now I'm going to start from this side. And then I'll add these up here. So this will be 7, and 7 is 14. That's 16, and here we've got 16. 16 minus 16 is 0. Is 0 divisible by 11? Yes, it'll go in 0 times. Therefore, let's take one we all know. 88, right? Take all the odd ones, add them. Take the odd ones, add them. 8. Take the even ones, add them. You get 0. 0 is divisible by 11, so. Or take 11 squared. You've all got it memorized, right? 121. Add those two, you get 2. Add that one, you get 2. Subtract, you get 0. So if you get 0, or what else would you have to get here for this to work? 11 or 22 or 33, some multiple of 11, right? For it to work. Okay. This isn't the only one for 11, but it's a fast one and it works well. 12. What are we going to do for 12? I'm going to let you put into words what I just did. I think putting it into words, in other words, how are you going to write this out so somebody knows what to do? I gave you an example. You need to write, after 11, here's what you do. Okay? Anybody know 12? Trick for 12?
The rules for 3 and 4.
The rules for 3 and 4.
You combine them.
You're saying that because of the way we did 2 and 6? Or 2 and 3 for 6? And the way we did 2 and 5 for 10? So could we use the rule for 3 and 4, or could we use the rule for 2 and 6? Either?
Actually, I read online that you can't quite do 2 and 6
Why not?
for 12 because they're not necessarily both exact primes.
Let's take 18. Does 2 work
Yeah.
for 18? Does 6 work? Yes. Does 12 work? No. So the trick 2 and 6 doesn't work. How come 3 and 4 works when 2 and 6 won't? Any ideas? That is the rule. For 3 and 4. If you do it for 3 and the answer is yes, and you do it for 4 and the answer is yes, then the answer is yes for 12. If I say yes, no, the answer is no for 12. If I say no, yes, actually if I say no, don't even check this one, because it won't work if 3 won't. Does that make sense? You have to have both. It worked for both 3 and 4. 13. Anybody know the rule for 13? Somebody take 13 times a 7-digit number and give me the result. 13 times any 7-digit number.
3, 5, 0, 7, 9, 6, 5.
I could divide this by 13 with short division. By the way, a 2-digit number for short division makes it much more difficult. Especially start getting up anything above 12, really. So let me just show you how we can do it. Starting on the right, we group these 3, then we group the next 3, and then we take the next 3, but there's not enough, so I just use these. So now what we do is we take every other group of 3 and add them together. This one with this one, I get 690, right? And then I would take this one, if it were bigger, I would add these 3 and those 3, right? But there aren't any. So you just, and if it was even bigger, I'd take these 3 and these 3 and then skip 3 and those 3. And so you add up the groups of every other 3, then you add up the groups of every other 3, and this is just going to be 79. I subtract the sum of those 2, and I end up with, what? 611, right? And if 13 will go into this number, it will go into the entire number.
But what if you have, like, I'm so what if you have another group of 3 on the left?
So let's make up another one here.
So do you
4,
just add
7,
those
5,
together?
6, 2, 0, 1, 9, 8, 2, 7, or 5, 7, 3. Okay? I'll take these 3, those 3, these 3, those 3, and what's left here. So everything that has a line above the 3, I'm going to add these together. So 573, 201, and 4. Does everybody see what I'm doing? Every other group of 3, we're going to add. We get 8, 7, and 7. Now I take the ones that were underlined underneath and add them. 5, 6, 9, 8, 2. We get 8, 3, 7, 1. Is that right? Now I what? Subtract the little one from the big one. And that gives me 0, then 6, and 9. Is that right? If this thing is divisible by 13, then this entire number is. And let's see here. 13 goes in 26, 39, 52. What do we? How many times will it go here? 13. 5 would be 65. 7 would be 91.
I think so.
91 would be, that's 7 times with a remainder of 5, so will 13 go into 50? Nope, then it won't go into this number either. I think that's quite a bit faster than dividing it by 3 still. Kind of an advantage. Did you know that this same trick of grouping by 3s and doing this number right here is the key. I've divided it by 13, but if 11 will go into here, then this number is divisible by 11. If 7 will go into here, then this number is divisible by 7. So once you get the groups of 3, add them together and subtract the sums. You can test it for 13, 11, and 7, and the trick works for both, for all 3, I mean. Does that make sense? So it's an alternative 7 trick, and it's an alternative, and if I've got a check for 13, then I could use this trick for 11 and 7 as well. Once I get to this number right here, just test it for 13, test it for 7, and test it for 11. And any of those that go into there, and you could use one of the other rules for 7 that we learned over here to test that out.
Does that rule always apply to prime numbers?
Why don't you,
Like the prime number rule?
because you're saying 7, 11, and 13 are prime. But it didn't work for 5, and 5's prime.
Well, 5 has like its own.
Right. So does it work for all the other primes, you mean?
I don't know.
Good question. You notice that 7, 11, and 13 were prime, right?
Would it work for 3?
Would it work with 3?
Maybe it would.
I don't know. This is divisible by 3, right? Okay, let's use what we know of before. That's 3. That's 12, so it's divisible by 3. That's divisible by 3. That's divisible by 3. Still got a 2 hanging out here. That's divisible by 3. 2, 2, and 5 is 9. It's divisible by 3. 4 plus 7 is 11. Is not divisible by 3. I don't think it works for 3 because this isn't divisible by 3, but 960 is. Okay. What about a number like 36 or 24 or 18 or
Can you take the multiples or the factors of them? So if like for 24, you could take the rules for 8 and 3. And then for 18, then you do
for 18, what should we check? 6 and 3. Okay, I'm thinking of the number 24. Does 3 work? Yes. Does 6 work? Does 18 work? So we can't use 3 and 6 for 18.
2 and 9.
2 and 9. Let's think of a number that 2 will go into and 9 will go into, and see if 18 will.
36.
36. 9 does 4 times, 18 does twice.
72.
And or 18 does twice and 2 goes into it. Yeah, 18 times. 72. 9 goes into 72. 2 goes into 72. That means 18 goes into 72. Does it? When we prime factor it, 8 times 9, that's 2 cubed, and that's 3 squared, right? Can I get an 18 out of this as a factor? How? The 2 9s, or the 2 3s making 9 and one of the 2s, right? So 18 is a factor with its partner what?
2.
How did you get 4? The 2 2s that are left after I put 1 2 with the 9, right? Does everybody follow that? So 18 is a factor of that. So how do you know which factors to use? 3 and 6 didn't work. 2 and 9 did. Anybody? Here's the trick. It is a trick. It's a thing that the factors that you come up with. Let's take 36. 18. Somebody said try 3 and 6. Somebody said try 2 and 9. 36. Let's get pairs of factors. We got 2 and 18, 3 and 12. What? 4 and 9 and 6 in itself, right? Could we use any of those pairs to check whether a number is divisible by 36? So could we check it for 2 and check it for 18? And if it's yes, yes, it will be yes for 36, or no? What about 54? Wait a minute, I'm thinking of 18 here, excuse me. 36. No, yeah, what about 54? 2 works, 18 works. 18 goes in there 3 times, right? But 36 doesn't go into 54 even with no remainder. Here's the rule. The numbers that you pick have to have no common factors other than 1. 3 and 6 have a common factor of 3. 3 goes into there and 3 goes into there. These have a common factor of 2. These have a common factor of 3. 3 will go into both 3 and 12, right? And 6 there. So 4 and 9 is the pair we pick. 12, remember we already talked about that one? 2 and 6, or 3 and 4. Well, 2 and 6 have something in common other than 1. What? The number 2. So that's not going to work. You have to use the 3 and the 4. So any number, you can actually break it up into factors, but the factors must have no common factors other than 1. We might as well give you that word right now. We say that they are relatively prime. What does that mean? 2 or more numbers with their greatest common factor of 1. That will be a good place to jump off. maybe before we go there yet. What about 16? Did everybody get that in the homework? 16, do you know the test for 16? Yes? No?
It's the 4 last digits of the number has to be divisible by.
How do you know?
Because last three digits are 8, and then the last 2 are 4, and the last one is 2.
We learned that to see if a number is divisible by 2, that's equal to 2 to the first, you check the rightmost single digit, right? For 4, which is 2 to the second, you check the the number formed by the 2 rightmost digits, right? For 8, which is 2 to the third, we check the number formed by the rightmost 3 digits. So 16 is what? 2 to the fourth. All you've got to do, you can take a great big number, all I've got to do is, does 16 go into there? If it does, it goes into this entire number. Why? Because 16 goes into 10,000 and it goes into 20,000 and all the multiples of 10,000. So that's why we've got to just check that. Therefore, 2 to the n, any number, we just check what? The rightmost n digits. So we could keep going and say 32 is 2 to the fifth. That check the rightmost 5 digits, etc. And if the number only has 5 digits, that's not a shortcut. Right? But if it's a very big number, if this is the number, and we're checking it for 32, all we've got to really check is, does 32 go into there? That's a lot better than dividing the entire thing by 32. Now, are you going to have calculators on the exam? Yes. How am I going to see if you've learned these rules or not? Because divisibility rules, you could just take the number and divide by the number with your calculator. That's one way I will have of doing it. I will use a number so big that none of your calculators will work. But if you know the tricks, you can do it pretty fast. Okay? Well, how else might I do it?
You might require us to write down like our word to show our word.
Yeah.
Or explain how we
All right. And for those of you who haven't had me in class before, when I grade a non-multiple choice test, and we always have some of those, if not all of them, the answer is not what I'm after. I'm looking at how did you get there. And you get more points for how you got there than you get for the answer, whether it's wrong or right. Now, I may have one like this. This 5-digit number is divisible by 3. What digit or digits might x be so that this is divisible by 3? How do you do a problem like this? What's the fastest way to do it?
You would cross out the 3.
Cross out the 3 because it's divisible by 3.
Add 4 to 5.
Add 4 to 5 and make 9. 9's divisible by 3
And then figure out what you can add to 7.
to make it divisible by 3. What would I have to add to 7 to make it divisible by 3? 2.
Make 9.
So x could be 2. Is that all it could be?
It could be 5.
5. 5 plus 7 is 12, and that's divisible. So it could be 5. Is that all?
8.
8 plus 7 is 15, and that's divisible by... She's using the very shortcut, right?
But technically you can't do, oh, sorry, never mind. I thought you were saying.
Anything else? I could add
'Cause you can't-
11 to 7, and that'd be 18. That's divisible by 3.
Well, that's what I was gonna say, you can't go above a single.
But that's
digit.
not a 1 digit.
Yeah.
Yeah, x is a digit.
Yeah.
So those are the only possibilities for 1 digit numbers that would make this work. Another way to take it would be to say 3 plus 4 plus 5 plus 7 plus x has got to be a number divisible by 3. So you add all these up, 7, 12, 19, right? 19 plus x has got to be a number divisible by 3. What could I add to 19 so it's divisible by 3? Well, 2, right? 21. 5, that would be 24. And 8, that would be 27. It's the same ones, but it's thinking about it a little bit differently than, okay? Okay. Would you mind coming over here with,
Yeah.
is it Victoria, working, and Kate, give you that? In your homework assignment, you looked at a greatest common factor and a least common multiple, right? And the way we introduced it to you in the homework was through what we call a list method. So if I have, I can't remember what numbers were in the homework, 12 and 20, okay? So 12 and 20, you were supposed to list all the factors of 12. So 1, 2, 3, 4, 6, and 12, right? 1, 2, 4, 5, 10, and 20. Then we had you underline the common ones. And that's all. And then after you've underlined the common ones, you circled the greatest common one. And there's, I recommend starting with children this method. Why? Because the name says it, right? Greatest common factor. You find the factors, you find the ones that are in common, and then just look at which one is the greatest. That is the greatest common factor. We're also going to learn some other methods. Why are we going to learn some other methods if this method works? Huh? Several learners that learn differently. There's another reason, that's very important by the way. There's another reason why we look at multiple methods. Why you need to know multiple methods particularly, and even your students should have multiple methods. Why?
It don't always work.
Everything I'm going to show you is going to work. If you don't have a method that doesn't always work, I don't know that you want that method.
Some kids might prefer a certain method.
I think that's what you were kind of saying, but in a different way. Yeah, the diverse learners.
It kind of backs it up.
Backs it up. What does that mean?
It proves it.
It strengthens the argument.
Yeah.
I maintain the more ways you can look at and understand a way of doing something, the deeper you understand it. Looking at multiple methods deepens understanding as well as gives diversity of different approaches. Those are both powerful reasons why you need more than one method. Okay? Why do you need to understand it deeply? Because you're going to be teaching it. And if the method that you're approaching with isn't working, you've got to say, well, I understand this deeply enough, I'm going to try it from another angle. Okay? So today, what I'd like you to do is we're going to learn another method. We're going to start by using blocks. And I'd like you to make a row that represents these two numbers. Since we already know the GCF here, we're going to verify it with this method. We're going to back it up with another method. So, you and your partner should have two stacks that look something like this. By the way, if no one has robbed your, yeah, do you want to come over and join? So 2 10s is a 20, right? And a 10 and 2 is 12. I'm going to show you a method to find the GCF, or sometimes called the GCD. Greatest common factor or greatest common, no, divisor. The greatest common divisor. GCD, GCF are interchangeable, but it's not divisor. All right, you ready? Get your 2, stand them up on your desk. Here's the algorithm. Right now, I don't care. Right now, I don't care that you understand how this works. I just want you to know what to do. So the algorithm is just, you stand them side by side. If they're not the same size, and they're not, you snap off the top so that they are, and throw away the bottom of the one that was taller. Then you put them together. If they're not the same size, you what? Snap off the top of the tallest one and what? Throw away the bottom. Put them together. Snap off the top, throw it away, or throw the bottom away. Throw away the bottom. Put them together. If they are the same, guess what? That's the GCD. Got it?
So how would you put that into words?
Snap off the top of the big one. Throw the bottom one away. Put them together. Repeat. Snap off the top of the tall one. Throw the bottom of the tall one away. Put them together. When do you stop? When they are the same size. All right, let's just try a couple of other numbers of some that we know the GCD so we can back it up with this method. Somebody want to give me a pair of numbers? 36 and 24. Okay, does everybody know what the GCD of this is? No, just go ahead. We'll find out. So you're going to have a 36. That's why you have a partner, so they don't crash and tip over. Okay? Hold on. 36 and 24.
Yes. Get rid of that.
You can lay them down if you want, but I think it's fun to put them up and, okay?
So 12 is our greatest common. So if we're writing this out, we would write what? Stand up. Say 12.
Are you calculating for stand? So it doesn't even make sense, but keep the section you snap off. That's just a little side note.